Welcome to 4.3. We're going to be looking at multiplication with fractions. That's going to be the primary focus here. So let's get started. Whenever we multiply two fractions, the result is called the product, just like when we multiply any two numbers. And when we do multiply fractions, what you'll notice is that we multiply numerators with numerators and denominators with denominators. So let's take a look at an example here. Let's multiply 3/5 times 2/7. So to do this, I'm going to multiply numerator times numerator and denominator times denominator. 3 times 2 is 6, and 5 times 7 is 35. Now, we always want to look for an opportunity to reduce our fraction, but what you'll notice is that all of these numbers here were prime numbers. So since they didn't have anything in common to start with, they won't have anything in common after we do the multiplication, because the only factors are prime numbers that aren't like. So hopefully that kind of explains why we're not reducing in this situation, but why we always want to be on the lookout to reduce to lowest terms in other situations. So when we're multiplying fractions, we basically just multiply straight across. We multiply numerator with numerator, denominator with denominator. So can we apply that to what to do with a whole number? Remember from before, whole numbers can be written as fractions over 1. So I can always multiply a fraction in a whole number. So 3/8 times 5, that's really like 3/8 times 5 over 1. Now, normally I wouldn't put 5 over 1, I would just write 5, but in this case it's more helpful to write 5 over 1. Now when I multiply fractions, I multiply tops and I multiply bottoms. So 3 times 5 is 15, 8 times 1 is 8. And so 3/8 times 5 is 15/8. Now in this case, 15 is made up of 3 times 5, 8 is made up of 2 times 2 times 2, and so they don't have anything in common. And so I can't reduce to any lower terms. It's already in its lowest terms. All right, so let's have a look at this example. So let's multiply 15 over 8 times 4 over 9. So when we multiply fractions, we multiply straight across, numerator times numerator, over denominator times denominator. 15 times 4 is 60. 8 times 9 is 72. Now, 60 over 72 is correct, but it's not reduced. So I always want to look for an opportunity to reduce to lowest terms. So what I'm going to do is I'm going to prime factor 60 and 72 and see how I can reduce. So 60, 2 goes into 60 and leaves 30. 2 goes into 30 and leaves 15. And 3 goes into 15 and leaves 5. So that's 60 done. Now let me do 72. 2 goes into 72 and leaves 36. 2 goes into 36 and leaves 18. 2 goes into 18 and leaves 9. And 3 goes in and leaves 3. So then the prime factored version of 60 over 72 is 2 times 2 times 3 times 5 over 2 times 2 times 2 times 3 times 3. And now I'll reduce any common factors, top and bottom. So 2 divided by 2 is 1. 2 divided by 2 is 1. 3 divided by 3 is 1. So all I have left is 5 on the top and then 2 times 3 on the bottom. So 5 over 6 is the reduced form of 60 over 72. And that's the answer that we want to put. Now, we could have reduced as we went. So what we could have done is, instead of waiting and reducing 60 and 72 at the end, I could have reduced as we went. So let's have a look. So I could have prime factored these numbers here. Might have been a little easier, because 15 I know is 3 times 5. 8 is 2 times 2 times 2. And that's all times 4, which is 2 times 2. And 9, which is 3 times 3. So when you multiply straight across. So that's 3 times 5 times 2 times 2 over 2 times 2 times 2 times 3 times 3. So by prime factoring the smaller numbers, what I can see here is that when I go to cancel any like factors, that I'm dealing with much smaller numbers. So I didn't have to do, I didn't have to do a table with my prime factors. I was able to just kind of know that 15 is 3 times 5 and 9 is 3 times 3. So I'm still left with 5 over 2 times 3, which is 6. So I can reduce the initial factors as I go, or I can multiply, get my product, and then reduce. So let's look at simplifying an expression with a fraction and an exponent. So here's negative 3/4 squared. So this means 2 factors of negative 3/4. Now a negative times a negative is a positive. So it's really 3 times 3 over 4 times 4, because when I multiply numerator times numerator, denominator times denominator. And 3 times 3 is 9, 4 times 4 is 16. And since they didn't have anything in common here when they were in their factored form, they won't have anything in common when I actually multiply. So 9/16 is the simplified version of negative 3/4 squared. Now let's do another one here. 5/6 squared times a half. So the order of operations says we have to evaluate exponents first. So this is 5/6 times 5/6 times 1/2. So 5/6 times 5/6 times 1/2. So I can multiply, when I'm multiplying 3 fractions or any number of fractions, I can go ahead and multiply all of them together. So this is 5 times 5 times 1 over 6 times 6 times 2. So 5 times 5 times 1 is 25, and 6 times 6 is 36, times 2 is 72. And since they didn't have any common factors here when they were in a factored form, they won't have any common factors here when they're multiplied. So that is in lowest terms. All right, so here's an example where we can use the distributive property. And so let's have a look here at A. 6 times 2 plus 1/3. 2 plus 1/3. I don't really know how to do that yet. So what I could do is I could just distribute the 6 times 2 and the 6 times a third and see what happens. So 6 times 2 plus 6 times a third. 6 times 2 is 12, and 6 times a third. Well, what I can do with the 6 is I can write 6 over 1 times 1 over 3, and 6 over 1 times 1 over 3 is 6 over 3. And 6 divided by 3 is 2. Oh, okay, so that's 12 plus 2, so 14. All right, let's do another example. Twelve times 3/4 minus a half. I don't know what 3/4 minus a half is, but I know I can use the distributive property here. So 12 times 3/4 is really like 12 over 1. And 12 times minus 1/2, right, is 12 over 1 times 1/2. So now I'll go ahead and multiply straight across. 12 times 3 is 36 over 4 minus 12 times 1 is 12. And 1 times 2 is 2. 36 divided by 4 is 9. 12 divided by 2 is 6. 9 minus 6 is 3. All right, let's do one more. Negative 5 times 4 minus 2/5. So it's negative 5 times 4 minus negative 5 times 2/5. So negative 5 times 4 is negative 20. And then a negative times a negative is a positive. So that's going to be plus 5 over 1 times 2 over 5. So that's negative 20 plus 5 times 2 is 10. And 1 over 5, or excuse me, 1 times 5 is 5. And 10 over 5 is 2. So this is really negative 20 plus 2. And negative 20 plus 2 is negative 18. Now, one of the reasons why we actually want to practice this is for figuring out the area of a triangle. Now, think about this. If this is some rectangle here, let's say that this is 3, let's say that this is 4 here. If I want to know the area of this rectangle, I can multiply length times width. But what if I want to know the area of this triangle? Well, the area of a triangle is half of the rectangle. So it's half the length times the width. But with triangles, we call it the base times the height. So the area of a triangle is equal to half its base times its height. So let's apply that. Here's a triangle. What's its base and what's its height? So the base equals 10 inches. And the height equals 7 inches. So then the area of the triangle is 1/2 its base times its height. So the area of this triangle is equal to 1/2 times 10 times 7. So that's 1/2 times 10. Half of 10 is 5, times 7 is 35. And because this was inches units times inches units, this is now in inches squared units. And so the area of the triangle is half the base times the height. And so that's why we need to be able to multiply with fractions. So let's review some of these concepts. Explain how to multiply fractions. Well, multiply numerators, aka tops, then multiply denominators, aka bottoms, and then reduce. And that's actually a step that we're always going to look to do. We're always going to look to simplify and reduce whenever possible, but especially with fractions. Find 1/3 of 6/7. So what is 1/3 of 6/7? Of on its own means multiplication. So let's go ahead and do this. That means 1 times 6 over 3 times 7. So that's 6 over 21. Now am I done? No, because I can reduce, because 6 and 21 are both divisible by 3. So 6 divided by 3 is 2. 21 divided by 3 is 7. So 2/7 is 1/3 of 6/7. C. Give an example of a problem involving fractions in which it would be helpful to use the commutative or associative property of multiplication. Well, an example would be when you have a whole number and a fraction. And that's when it would be most useful to use the distributive property. The commutative property or associative property. So the commutative property, then it would be most helpful in an example like where you were multiplying and you wanted to reduce. So for instance, let's say 2/3 times 1/5 times 1/4. So what I notice is that this 2 and this 4 have a common factor of 2. 2 goes into both of those numbers. So when I eventually go to write them, it actually would be more helpful for me to write it like this. When I write it like this, I need to know that the commutative property is at work with multiplication and the order doesn't matter, and that this 2 here can cancel with this 2 here even though they're out of order. So that's a good example of how the commutative property helps us to resolve fraction problems with multiplication. Now D, find the area of a triangle with a base of 9 inches and a height of 12 inches. Well, the area of a triangle is half of its base times its height, because a triangle is half of a rectangle. So the area is half base, which is 9, times height, which is 12. Well, here's an example where the commutative property would really help me, because I don't know what half of 9 is as well as I know what half of 12 is. So I could easily write this in a different order because the commutative property of multiplication allows me to do that. Half of 12 is 6, and 6 times 9 is 54. So that's 54 square inches, and you can also write it SQIN. So that is the area of that triangle. So hopefully this answered some questions about multiplying fractions. And if you have questions, let me know. Otherwise, I'll see you in the next section.